I'm Aspen, and I did the chemistry of kaleidoscopes for my project for Mrs. Ellis's class. So I'm going to tell you all about that. Okay, so if I'm going to tell you about kaleidoscopes, the first thing you have to know is where they came from and their origin and what the word means. So, a long time ago, some Greek dude made up the words kalos, which means beautiful, eidos, that which is seen, and scopio, to look or examine. So, those all put together means the observation of beautiful forms. So, like looking at me or Miss Ellis or a kaleidoscope. That's what it means. So, it wasn't the Greek dude that invented the kaleidoscope. He just invented the words that we could use someday to form the kaleidoscope so that we could also describe me and Mrs. Ellis and our sheer beauty. But anyhow, this guy named Sir David Brewster invented the kaleidoscope in 1815, and he was a scientist that was working on experiments towards light polarization and just invented this kaleidoscope by accident and introduced it to the public to see what they thought about it and to see how they thought scientifically about it. And it turns out that they didn't really like it scientifically, they just liked looking through it because it was cool. And so he was kind of bummed out about that, but then he realized that there was a big market for that, so he patented it 2 years later in 1817 and entered it into the toy market, and now it is used today as a toy. The basic principle of a kaleidoscope is a long tube that has multiple mirrors along the inside of the tube, and it twists. And at the end of the tube, at one end of the tube is an eyepiece for you to look through, and then at the other end of the tube is a little compartment that houses either plastic objects, glitter, whatever you put in it. A lot of times it's just plastic or glass objects. And as you turn the tube, the objects move and the reflections change. So usually the mirrors are placed at 60 degrees next to each other, and the mirrors are rectangular, and the mirrors are placed so that they form an equilateral triangle. So when the light shines through the tube, it shines onto the colors, which then shines into our eye. So the visual spectrums of color range all the way from infrared light to ultraviolet. And the wavelength for each color is different, and it's measured in nanometers. So this is the wavelength for each color. Red is 620 to 780 nanometers, orange is 585 to 620 nanometers, yellow is 570 to 585 nanometers, green is 590 to 570 nanometers, blue is 440 to 490 nanometers, indigo is 420 to 440 nanometers, and violet is 400 to 420 nanometers.